Okay, so now we will have Dr. Chase Sherwell, and he will share with you the work that he's been doing with Marta Education. So, Dr. Sherwell is a cognitive neuroscientist and research fellow in the UQ Learning Lab. His research focuses on developing multidisciplinary approaches to understanding learning, well-being, and mental health. Combining wearable biometrics, app-based psychometrics, and behaviour, Chase's work mobilises findings from the lab into real-world contexts. Chase's work has so far contributed to learning design, intervention development, and an understanding of how individual factors affect learning and performance. Thanks, Chase.
Thank you very much, Sasha. Good afternoon, everyone. Thank you for sticking through till this afternoon. I know everyone's very keen to get to their weekend, so I will try not to bore you too much with my presentation today. So one thing I think that's become abundantly clear over the last 3 years is the importance, but also the vulnerability of our healthcare system. And unfortunately, in Australia, we are facing a significant healthcare labour shortage. Despite the fact that Australia has produced more nursing graduates than any other OECD country over the past 10 years, it is expected by 2025 that there will be a shortfall of 85,000 nurses nationwide. It's more important than ever that our education systems can generate a new generation of healthcare workers. It's also critical that this training is both scalable and sustainable to meet future needs, efficient in terms of time and cost, and produces graduates that are ready to deal with the realities of the modern healthcare environment. Simulation training has been touted as one of the best methods for producing work-ready healthcare professionals. Simulation training has been widely adopted for undergraduate training, but also quality improvement and professional development in nurses, clinicians, and allied health professionals. It's used widely across all healthcare professions in training and also in interdisciplinary teams like emergency unit teams. And with rapidly declining opportunities for clinical placements, there have been pushes for simulation training to replace clinical placement hours. One of the reasons why simulation training is seen as so effective is that it not only allows trainees to develop technical skills, but critical non-technical skills that have previously only been afforded by occupational experience. These non-technical skills like decision-making, teamwork, task and stress management are all the hallmark signs of expert healthcare professionals. And in fact, a significant number of clinical errors have been attributable to deficits in non-technical skills rather than technical skill deficits. Working closely with Marta Education, their healthcare educators have identified a number of significant factors to delivering effective simulation training. First of all, educators currently lack a standardized way of measuring non-technical skill development. They often rely on either pure observation or long-term assessments, where you find out about skill development way down the track when it's too late to do something about it. Another issue is that the learning processes that contribute to skill development are often hidden or unobservable or difficult to observe just in the classroom. And as a more higher level issue, exactly how trainees learn non-technical skills in simulation training is still relatively unknown. These challenges have significant impacts for training. It inhibits targeted feedback, which inevitably reduces the scalability of simulation training, especially with increasing cohort sizes. It also reduces the learning gains and the efficiency of simulation training overall, which isn't an unlimited resource. Simulation training is somewhat costly and takes time and only occurs within the classroom. It's not something that students can take home. And finally, it might produce graduates that are ultimately less well prepared to deal with the work, to deal with the healthcare environment. Ultimately, all this means is that educators need a means to identify and monitor learning, a way to track skill development over time, and a framework for what works in simulation training. Co-developing a project with Marta Education has been an incredibly rewarding experience. And we have designed a long-term project that has three main aims. First, we're looking to identify the critical learning processes in simulation training that lead to work-ready graduates. We also want to adapt and integrate measures of learning and skill progression into simulation training so that people can efficiently deliver feedback and provide targeted simulation training for who and what is needed. Finally, we want to develop a sustainable and scalable learning design framework that embeds real-time measures directly into training. This project would not be possible at all without the two-way mobilization between the UQ Learning Lab and Mater Education. Mater Education is a nationally recognized leader in simulation training, and working with them closely, I know I have learnt so much about this really fascinating area. The ultimate goal of this work is not to tell educators at Mater Education, and indeed, in simulation trainings around Australia, how to do their job. They're the ones who are the experts in this field, not us in the Learning Lab. It's only through working closely together with them that we can identify these critical challenges and provide educators with the tools they need to do what they do best. So starting off, we are currently conducting some pilot research into identifying the critical learning processes that underpin successful simulation training. We're doing this in nursing undergraduates at Mater Education who undertake problem-based learning simulation training. This is where first-year nurses come in to the simulation lab and they're faced with a realistic clinical scenario, and they have to use their clinical judgment and the skills that they've learnt to solve the challenges presented in that clinical scenario. We're using a multimodal approach to try and get different perspectives on the different types of learning processes that might be taking place during this type of training. First, we're using app-based psychometric scales that the participants complete before and after each training session. We're also measuring physiological activity throughout the training sessions using these biometric devices. So these wristbands measure skin conductance, and these lightweight heart rate monitors measure heart rate continuously. We're also using the self-assessment activities that are already embedded in simulation training as a way of collecting data itself. By collecting these different modes of data, what we're hoping to do is through psychometric scales, understand the attitudes, traits, and abilities that students are bringing into training, understanding how learner states and how these states change over time and in reaction to different learning activities, might tell us something about learner self-efficacy, but also the gains that they get from that simulation training session. We're using a longitudinal approach, so we're hoping to track these effects over time, over the course of 6 simulation training sessions, and then see how this is related to their competency assessments at the end of the course. This is just the first step in our research, identifying the critical learning processes in simulation training. There's still much more we want to do, but this is the first step in understanding what processes lead to non-technical skill development. Once we have a firm understanding of what contributes to non-technical skill development, it's important to adapt these more kind of scientific measures into educational tools that educators can use themselves. So physiological measures taken by biometrics can give us really important insights into cognitive load, stress management, and also, in some instances, social dynamics of teams. However, they often require some technical expertise to actually interpret these measures, which is obviously a barrier for educators. Traditional psychometrics can provide us very valid and reliable information on learner traits, subjective states, and student attitudes and beliefs, but they're incredibly time-consuming and don't seamlessly blend into a training regime. Some of these surveys take up to like 30 minutes, for example. It's not easy to just embed that into learning design. And finally, the formative assessment that already takes place is fantastic for measuring things like metacognition, self-evaluation accuracy that Natasha spoke about earlier, but also people's own skill monitoring. However, traditional pencil and paper approaches make it difficult to collate the data, track it over time, and for educators to use that information readily to get a big picture idea of how skills are developing. To tackle this, I will be working very closely with education management and education designers at Mater Education to design biometrics that provide the relevant information that educators can use. We also want to convert traditional psychometrics into interactive experience sampling methods. These are based on just smartphone apps where participants can, students I should say, can readily report their current states during training seamlessly, quickly, and intuitively. Finally, we want to integrate learning activities onto a digital platform to enable the collation of data. And by taking these different viewpoints on skill development and integrating them, we can provide educators and students themselves with a holistic view of skill development. So the ultimate goal of this is develop a learning framework that embeds skill monitoring. And the way we envision this is something that provides an overview of the different necessary skills that make expertise in healthcare. These can include things like procedural skills like clinical competency, regulation skills, things like fatigue management, stress management, interpersonal skills like teamwork and communication, situational awareness, which is the ability to select relevant data from the environment and plan forward. And finally, metacognition, which underpins important non-technical things like decision-making, strategic flexibility, and self-monitoring. It's our what this might look like is the development of things like teacher dashboards, where they can get a big picture view of skill development in real time and for individual students and larger cohorts as well. These can integrate real-time measures and allow educators to know who needs direct feedback, who needs intervention and guidance, and when. This is also important to provide students themselves with the opportunities to track their own development. Natasha gave an excellent overview of how important this is for self-evaluation, self-efficacy, and overall development of metacognition. So we still have a long way to go. However, I'm feeling incredibly optimistic about the opportunity to work closely with Mater Education to develop sustainable, scalable, and efficient training frameworks that will provide the next generation of healthcare workers that are ready for the healthcare environment.
Thanks, Chase. That was fantastic. Does anyone have any questions for Chase at the moment? Oh.
Thank you, Chase. That was really super interesting. What an amazing project. I just wonder, you mentioned social dynamics and physiological measures relating to those dynamics. I just wondered if you could talk a little bit more about how you measure that and how you interpret that kind of data.
Yeah, absolutely. Some of the previous work that I've done with Stephanie McMahon and Anne-Marie Carroll has been looking at a phenomenon known as social synchrony or physiological synchrony. And this is the tendency of individuals who are collaborating or cooperating or in some way interacting for their physiological signals to synchronize to certain extents. From a lot of work in organizational psychology, it's clear that when there are clear task goals and task roles within a collaborative team, you see a high degree of physiological synchrony. You see breakdown in this physiological synchrony when there aren't clear task roles or when task goals change and not everyone seems to be, I guess, cognitively synchronized in the direction they're going. So monitoring these dynamics of interpersonal physiology can potentially give insights into when there is communication or interpersonal breakdowns.
Thanks so much. That was really interesting. My question is for you, and it might be a question for Steph as well. Do you see that some of these principles could be replicated into the our other adult learning fields? And I'm thinking specifically of teacher education or teacher professional learning as well.
I think that's a fantastic question. I absolutely think it can be. I think it also, in particular, I can only really speak to my own project, but obviously non-technical skills are critically important for educators and teachers in particular. I've already been in discussion with Marta Education about taking this kind of framework for first year clinicians while they're on the ward and using some of these measures, especially like the kind of more journal taking experience sampling and biometrics as a tool for them to reflect on their own practice in those critical early years of placement. Now, I can imagine something could be similarly applied to teachers when they're on placement as a way of giving them information about how they're doing. I think there was another question over here. Or no? Resolved? We can talk afterwards. I'm happy to talk afterwards today as well. Oh,
I was just going to ask about like, what's the degree of accuracy in terms of, because you know it's a simulation situation in terms of your biometrics, like kind of, you know, is there the same kind of level of reaction when you know this is practice than if it's kind of the real thing? Like, it was interesting to hear at the end that you said, I want to put this into first year as well.
that's a fantastic question. And it has been an area of research in simulation training. How well does simulation training translate into the real world? Simulation training can take many forms, from like very low fidelity, like role playing with just a mannequin in everyday situations, all the way up to very high fidelity situations like practicing surgery on very like technical mannequins. One thing that to answer it very briefly, one thing that we are investigating currently in our pilot research is the balance between stress and challenge. And so we're specifically asking participants, how challenging do you think it's going to be today? How stressed are you about it today? And then using the physiology to measure that. One of our long-term plans is to follow a cohort during training and then on their clinical placements to see exactly how well those things match up. But you're exactly right. It is a broader issue for the kind of fidelity of simulation training. But part of the point of simulation training is that it's a safe environment to take risks as well. So it's balancing those two things.
Fantastic. Thank you so much, Chase.
Thank you.